Hello, fourth graders. Guess what? That's a tape diagram. I know, right? It doesn't look all that threatening, and yet it might be. Yes, that's just a simple subtraction problem. You take a total of 24, you subtract 3, and then you subtract 8, and what do you get? We don't know, so right now we're going to call it x, because x is the unknown variable, and right now the answer is unknown. Now, this is just basic tape diagram usage. I know that you may choose not to use it at your peril because ultimately you will need to learn how to use it. So, why not start today? It could be fun, really. So let's take a look at this. And I've got a second example here. So we have 35 minus 17 minus 5 equals x. So how would I fill in the blanks here? Well, maybe you want to take a stab at this before I try. You can pause it right here, kind of have a little thought experiment. Okay. Maybe you drew something like this. Yes, those are lines. Those aren't ones. I know that that might seem a little bit poorly drawn, but just work with me here. It's fast. Actually, this was like probably 3 years ago. So I'm going to just pretend that was fast and I had a lot more other things to do. This is definitely from about 5 years ago, but it's a good point nonetheless. Proper use of the tape diagram. So here's an example. A company has 3 locations with 70,070 employees altogether. The first location has 34,857 employees, and the second one has 17,595. Are those totals important? No. What's important is you know where to put them. So you have a total for the 3 locations of 70,070. That's what you see in the tape diagram as your total. You have parts of that total. And then you're going to be asked to solve for the unknown. The unknown is how many employees work in the third location. There it is. So, in the same way that I set up those other example problems, you're going to have that one unknown. And then when you go ahead and execute, it's just a simple subtraction problem. And notice I'm not giving you the answer on any of these because right now I'm not concerned about that. Right now all I'm concerned about is that you understand at a basic level how to set these problems up. Oh, look at that. We have a change in background. So let's take the first example here of 70,070 minus 34,857. You've done this kind of subtraction before. This kind of combines the last couple of lessons. What's different here is you actually have to borrow not only across zeros, but to cover the last zero on the end in the ones place. Watch what happens. So there I go. I'm going to borrow from the 7 to bring the 10 over into the ones place. So now I have 10 ones. And today I'm going to go ahead and do it a slightly different way. This may be the way that other people do it. I know I tend to kind of borrow all the way across and then do my subtraction. I'm going to offer this example in another way that some people do it, which is just do it one bit at a time. In other words, one place value at a time. So I have 10 minus 7, which is 3. I have 6 left behind, which doesn't require me to do any borrowing and regrouping, which is nice because 6 minus 5 is 1. But I look to 0 in the hundreds place and I'm thinking, oh, dude, you have to do some borrowing. And in fact, you can't borrow for the next place value over, which is the thousands, because the thousands place has what? A 0 in it. I have to change that. So I'm going to go all the way over to the 10,000th place. Watch what happens. There it is. I went all the way over to the 10,000th place. I reduced that by 1. I added the 10 to the 0, but then I had to borrow again because I also needed to bring 10 over to the hundreds place. I hope you're savvy to that. In fact, I would say you probably are based on the results from yesterday's work in class. So I'm going to go ahead and finish my subtraction, and off I go. So 10 minus 8 is 2. 9 minus 4 is 5, and 6 minus 3 is 3. So my answer there is 35,213. Now remember, this is a two-part problem. I had to subtract both of those numbers. You will probably end up with a problem that you have to do two different calculations like this. So I'm going to take what's left and subtract the smaller number. There is another way to do this. I know Mateus is thinking right now, Mr. C, what if I added those two numbers first and then subtracted that sum from 70,070? Yes, you can do that, but I'm not going to do that here right now. More borrowing involved. You can see that I created a 0 by borrowing the 1, but I was going to have to borrow there anyway. From the hundreds place, I borrow 100 and make that 10. And I already started the subtraction. So in the ones place, 13 minus 5 is 8. The tens place, 10 minus 9 is 1. I had to go all the way over and borrow from the 5 to make the 11. In other words, I turned the 1 into 11 by adding the 10 that I borrowed from the thousands place. So doing the subtraction, 11 minus 5 is 6. Now I've got one more place value to deal with here, actually 2. I can't subtract 7 from 4. I have to do some borrowing and regrouping. That 4 becomes 14. The 3 in the 10,000 place becomes 2. I continue my subtraction. 14 minus 7 is 7. And 2 minus 1 is, yes, 1. So guess what happens? My x value is 17,618. And that's what it looks like as a finished product. Isn't that exciting? You can say yes. And that's locations 1, 2, and 3. If you need to go back to the previous slide, now is a good time to do that. Just go ahead and scroll back and take a look at what I initially offered you as a problem to solve. So, on to the next one. That's right. But wait, there's a better way. Yes, you knew this was coming. In fact, Mateus was thinking, yeah, dude, I knew this all the time. Take that. So this is a word problem. It's a two-step word problem, as we like to say. Don't start running in the opposite direction. Stay in your chair. I know it looks a tiny bit scary right now. It'll be fine, really. So I'm going to read the problem to you, and we're going to tear into this thing. So it's a two-step word problem modeled with a tape diagram assessing reasonableness of the answer using rounding. What? I will show you what that all means. Owen's goal is to have 1 million people visit his new website within the first 4 months of it being launched. Below is a chart showing the number of visitors each month. How many more visitors does he need in month 4 to reach his goal? Now, you could probably say to yourself, okay, well, Mr. C, I already know the answer to this question. My goal is 1 million, and if I add up all three of those numbers I have in the first 3 months, my difference should end up being what I need for month 4. As I'm looking at that, it's not going to be a whole heck of a lot, but let's go ahead and, by that I mean it's going to be less than the other numbers you see there. But let's go ahead and try this one on. What will you do first? Well, how about adding? You want to add the first 3 months, right? Because you're going to have to subtract them from the total. What? Those 3. That's right, it's true. So I'm going to take the sum. And like I said, this is probably what Mateus was thinking. So Mateus, congratulations, you knew the answer. And so I'm going to go ahead and add those. I kind of fast forwarded that so you can just see the procedure. I'm not going to go through how I did it. You're just going to have to trust me on this one, you all. So that's the number of visitors, 829,609 so far in the first 3 months. What's left is the last month. I have a goal of 1 million people. So what I'm trying to find out is how many more people I have to add in the 4th month to reach my goal. Now, if it's me, I'm thinking I want to exceed that goal, which means go past it. But for now, let's just live in the not real world. There's my 1 million goal. There's my 829,609 to this point after 3 months. I'm going to subtract that to find out how much I have left to make 1 million. I do have to borrow all the way across on the zeros. Look at that. That's just crazy, man. So I went ahead and did that because, well, I really had no choice. I had nothing but zeros in those 6 place values. So what I end up with is this, 170,391. The subtraction isn't difficult. It's the setup where I think you guys might get stuck, if you get stuck at all. You may be looking at this and saying, Mr. C, piece of cake, let's go. I'm ready to roll. In which I'd say, congratulations. Now check for reasonableness. Well, how do you do that? And this is the part where things kind of start to fall apart for some kids. Not because the math is difficult, but because they think they should be rounding their answer. Never round your answer. I know there are still 2 of you who are thinking, wait, do I round my answer? No, you don't round your answer. You have to round the numbers before you create your answer. So I'm going to write those 3 numbers down one more time. And those arrows mean that I'm not creating equalities, I'm creating estimates. I've decided to round to the nearest 100,000 because these are big honking numbers, and that just seems to be the easiest thing to do. I don't like to work with a lot of the numbers to the right of the 100,000th place when I have numbers this big. It doesn't really help my estimate that much in this case. And really, I just want to find out if my answer is in the ballpark. And so that's this will do, okay? So I'm going to take my rounded numbers. I'm going to find their sum, and then I'm going to subtract that estimate from the 100,000 goal. I'm sorry, the million goal. And I end up with 200,000. Don't know where the 2 went. Oh, there it is. So I have an estimate of 200,000 as the difference between those two. So our answer was 170,391. And some of you may be thinking, okay, Mr. C, tell you what, dude, you know, our estimate is 200,000. That's like a 30,000 difference. You know, I know that seems like a lot, but given the fact that both of these numbers are in the 100,000s, it's fine. What you're trying to protect yourself against is making an estimate that's making a mistake that's a place value mistake. So for example, or just in terms of calculation, let's say for example that I ended up in, when I did my actual calculation with a number like 270,000 or 370,000. My estimate's that's only about half of that is going to show me that I've made a huge mistake somewhere, that I need to go back and check my calculation in the original problem that got me that answer. But the 2 numbers are close enough together that I'm satisfied that I've hit the mark. Now, could I have made a mistake still? Sure. But without a calculator or something like that, I may not know. So, is our answer reasonable? Is the question? Yes, it is. And you'll be seeing problems like this in the homework set today. Why or why not? And I think I just got through explaining, but I'll go through one more time with feeling that the 200,000 is close enough to 170,000 that I can say, yeah, I think my answer is reasonable. Again, the example I offered is if you have a value that would be, let's say, half of that, like say it was somewhere near 100,000, you made a mistake. That's not a reasonable, your answer is not reasonable based on your estimate. The reason I say that is because your estimate is always going to be easier to calculate. Why? Because it's got lots of zeros in it, dude. And those are easy things to deal with. So go ahead and take a whack at the homework. But if you are locked up even before you start it and want to ask a couple of confirming questions, clarifying questions, by all means, hit me up and we'll take it from there. Anyway, thanks for listening, guys. Kind of a longish lesson, but this is a big deal. Talk to you soon.